Now, can you please verify? Transport layer, how many types protocol we discussed?
Two.
Two protocols, TCP and UDP. Yes or no? So right now, if someone says, I'm using reliable protocol, that means reliable means we are using TCP and we are using a TCP protocol. That means how many features available? Connection oriented, sequencing, data flow, reply, and acknowledge. Basically, UDP also a protocol, but UDP call it's an unreliable protocol. Why? Whenever user send data, whenever user receive data, so never send back any reply or acknowledge. That means sender never get any information. Destination person receive or not receive. Clear? In UDP protocol, we are getting a features. It's a connectionless, no sequencing, no reply, no acknowledge. Data delivery is guaranteed in UDP? No. But via UDP protocol, your data traffic will be processed quickly. Yes or no? Because UDP header size is how many bytes? UDP protocol header size 8 bytes. And TCP 20 bytes. You can verify. UDP header size 8 byte and TCP header size is 20 byte. So that is the reason. Okay. So basically today we discussed first a TCP protocol features. Which one protocol features, dear? TCP protocol features. Okay. Give me 1 second now. So write down TCP protocol features. Which one is first feature, dear? Which one is first feature? Which one? First feature name is connection oriented. Okay. Why we use connection oriented feature? So only clear first line. Whenever device trying sending a data, or you can say whenever device trying to communicate. Clear? There's two things. Then device is also you can say device before doing any process, first process will do three-way handshake process. Which one process we do first? Three-way handshake process. If you are sending data, if you're trying to communicate, so first we do three-way handshake process. So what is the meaning of three-way handshake process? For example, this side we are getting a user. This user name is Bob. And this side we are getting a one more user. Its name Sam. So both are connected with which one connectivity? This one, wired or wireless? Anyone know?
Wired.
Oh, very good, very good. Now Bob say, brother, I want to send some data. But Bob say, if I'm using a data and via TCP protocol, if I'm sending, so this Bob user will do first three-way handshake process. Which one three-way? Bob say, I'm sending first message. In this message, Bob say, I want to set up a communication with you. Bob say, I want to set up a communication with you. So this one is my first message. This one is my first message. And now second message. Whenever Sam receive this message, Sam send back one more message. Okay. Okay means I'm receive your data. I'm receive your message. And after okay, inside okay message, one more message forward. start your communication. Which one message we are sending? Start your communication. So can you please verify, brother? Bob say, I want to set up a communication, and Sam say, okay, I'm received. So that means this message, reply message, we are successfully received. But start your communication message, Sam can be possible to receive reply. Yes. Whenever Bob receive this message, okay, start your communication. Bob say, okay. Okay means my first message reply I'm received. And now Sam say, start your communication. So Bob say, okay, now we can start. So how many steps this process will complete? Verify.
Three.
How many steps?
3.
1, 2, and then 3. So it's called three-way handshake process. But this one is non-technical. Now we discuss technical. In real time, this process will happen every time whenever we are using a TCP protocol. Now, this one is wired connection. Now, basically, if we are using, brother, TCP protocol, so in TCP protocol header, inside header, we are getting some field. Clear? Inside field, we are getting some flags. If you know, if you are going for if you are watching a race, so we are getting a flag. If you win, so flag will be available. So same in TCP header also we are getting some flags. These flags will define process. We are getting 6 type of flags. We discuss later this flags information deeply, but right now 6 flags available: sync, acknowledge, fin, push, reset, urgent pointer. Clear? So basically sync means I want to synchronize. Synchronize means both devices same information will receive possible. Acknowledge means how much data we receive. Fin means close your session. Push means sending your data. Reset means if you refresh your windows, so process will be again start. Urgent pointer means prioritization. Which type of data traffic first go? Voice traffic or normal data traffic? So you can do. Okay, this flag, if we are getting a 1 bit, that means we are using. That means we are using means on. If we are getting a flag is 0. 0 means we are not using. That means flag is off, not in use right now. So basically in this condition, Bob say, I am using some data via application and I want to send Bob to Sam, but we are using TCP. So Bob say, my first message is synchronize. Synchronize means I want to set up a communication with you. And now whenever Sam receive this message, so Sam send back which one message, dear? Acknowledge. That means I am successfully received your data traffic or communication message. Clear? And after acknowledge, inside acknowledge, one more message build. It's called synchronize. Sam say, okay, I'm sending acknowledge message. That means I'm received. And I'm also sending synchronization message. I also want to start my communication. That condition, Bob say, okay, my first synchronization acknowledge is successfully received. And now Bob say, I'm sending acknowledge message. For which one? For Sam synchronization message. Clear? So how many steps process again complete? Verify.
3.
1, 2, and then 3. So whenever we are using a TCP protocol, so TCP protocol every time, which one process will follow first before sending data, before doing any communication? Which one process follow? Three-way handshake process. Clear? Now, one more thing. Second feature. First feature is clear, connection oriented. Now second feature. Second feature name is sequencing. Which one feature, dear? Sequencing. Sequencing also very easy. Whenever devices want to send, receive data traffic. Then check. Okay. MTU size. Anyone know? If this one is PC, so how many option available to forward your data traffic on another PC side? How many option available? How many way to forward your data?
Wired and wireless.
Wired and wireless, USB. USB also option, na? Okay.
Yes. Yeah.
If I'm using wired or wireless, so basically wired or wireless connection we can get from network interface card. Yes or no? So network interface card, every network interface card having a MTU size. Which one size, dear? MTU size. Clear? This MTU size will define device how many size data send or receive. So basically one more thing you can say, MTU means maximum transfer unit. Clear? One more thing, MTU available on which one location, dear? NIC card. NIC card means network interface card. MTU. By default, 1500 byte a size. How many MTU size, dear? 1500 bytes. MTU. Already 20 byte reserved for IP information. Clear? One more thing, MTU. So how many size data now we can possible to process or receive? After 1500 minus 20, how much data?
1480.
Clear? If I am using TCP, so again minus 20. Yes or no? No. One more thing. For example, this one is user Bob. This one is user Sam. Now, Bob, this interface, this NIC card MTU size is actually MTU size is 1500 byte, but after receive IP, we are getting how many size of MTU? 1480. This one also MTU size is 1500 bytes. And this interface actually, how many after minus 20 for IP? How many bytes?
1480.
1480. Now, Bob say, brother, I want to send data. But Bob, actually data size is how many bytes?
2000.
So via single box, this cable, this interface possible to send?
No.
No. This interface possible to receive?
No.
So in this case, Bob in backend, if using with data, which one protocol? TCP. So this data we are getting a which one task, dear? Which one task? Slicing. Slicing means how much data in single box we can travel via this port? How much data we can travel? 1480. And how many data remaining after minus this data from 2000? How many data remaining?
520. 520.
520. Very good. But can you please verify this board data via single box or multiple box? We are getting a single packet, yes or no? So in this case, this 1480 520, a sequence number is how many, dear? Sequence number is how many? One. Because both data traffic will belong from single. Now, But which one is my first slicing part? 1480 or 520 is my first part slicing. Which one is first box? 148.
1480.
So this one is ID number 1. This one ID number is 2.
2.
Now, Bob will possible to transmit and Sam possible to receive.
Receive.
Sam say, brother, I am receiving your data 520 first, and then after I am receiving 1480. This one is sequence number 1, ID number is 2. This one is sequence number is 1, ID number is 1. Clear? Any doubt? Now, can you please verify? Bob say, brother, please send me acknowledge. How much data? 2000 bytes. Please send me acknowledge for how many bytes data? 2000 bytes. Sam say, brother, wait. I'm receiving first data 520, then I'm receiving 1480. How to say this both packet belong from single? How to say? So in this condition, Sam will verify both the data. How many sequence number, dear? Same or different?
Same sequence.
Same. So in this condition, Sam say I am doing one task. Which one, dear? Which one task?
Reassembly.
Reassembling. Reassembling means Sam will say, okay, my first data 1480 with sequence 1, ID number is 1, and then 520, sequence 1, ID number is 2. Now, after combine this one, Sam will send back how much data acknowledged here? 2000 easily. Any issue for this thing?
No.
Sequencing? No. Third task. Third task is flow control. Flow control is also very simple. Whenever device trying to can you hear me? Loyal, Neil, Gopi.
Yes.
Okay. Whenever device trying to process data in buffer memory, then check flow control method. In this method, device check how much packets can process within a second. Okay. If you're having a mobile phone, so some mobile phones, if you open multiple application, so we are getting a processing is slow automatically. Yes or no? But some mobile phone, if open multiple application, we are not getting any impact processing. How it possible? Because device having a processing plus a buffer memory. Buffer memory means a cache memory, temporary memory, a higher size. Clear? So flow control is very simple. For example, this side we are getting a username is Bob. This side we are getting a username is Sam. And both are connected. But right now Bob say this interface actually someone set MTU size is how many bytes dear? Manually. How many bytes? 200 bytes. This one interface someone set network engineer how many bytes MTU size? 200 bytes. Clear? Now Bob say I want to send a data, but actually my data size is how many bytes dear? How many bytes?
1000. Okay.
Sam say, brother, I'm having a buffer memory. How many packets we can process? How many packets within a second we can process? 3 packets. Clear? If we are sending 3 box, then I will process within a second because my buffer memory space is how many packets within a second? 3 packets. Now, how flow control will work in this scenario? Now, if I am trying to send this 2000 byte data in single box via this link, so possible?
No.
No. Because MTU size is how many bytes?
200.
So we need to perform slicing. And now how many box we create? Any idea?
So you have to divide it
10.
to, yeah, exactly. So 500, 500, 500, 200, 200, 200, and so on.
10 boxes, I guess.
10 boxes. Very good. Clear?
Yeah.
Now, Bob say, I'm creating a 10 boxes to forwarding 2000 byte data. And now Bob say, I don't have any idea how many box Sam will process within a second. So Bob say, I am sending which number of packet? First number. Clear? Single box. And Sam will say, okay, I'm received and I will put into my buffer memory and I have more than single box space. Yes or no? And within a second, Sam will process and send back which one message, dear? Acknowledge. For which one box? One. Bob say, okay. Bob say, okay, brother, if I am sending single box, so you can process within a second. That means you have more than one box memory. So Bob say, now I am sending how many boxes?
2.
How many boxes? 2 and 3. Sam will say, okay, brother, I am received and I will put into my buffer memory. Again, I have more than 2 packets, 2 boxes space. So in this condition, Sam will send back immediate. Which one message? Acknowledge. For which one?
2 and 3.
Bob say, okay, now I am getting confusion because single box within a second, 2 box within a second. Bob say, now, brother, I am sending how many box? How many box?
3.
3 box.
4, 5, and 6.
Yeah. Bob, Sam will say, now, brother, no issue. I will put in my buffer memory and I have more than three boxes of space. And Sam will immediate process and forward which one message? Acknowledge. How many box we can process? 4, 5, and 6. Bob said, now this thing is not good. If I'm sending single box, so you can process. If I'm sending 2, you can process. If I'm sending 3, so you can process. That means you have more than 3. So Bob said, now, brother, I'm sending how many box? How many box? 7, 8,
8, 9, 10.
Sam said, brother, younger brother, I don't have space. 7, 8, 9, I will process, but 10 number will drop. Yes or no? So in this condition, Sam will send back how many boxes acknowledge message? Any idea?
4.
4.
4. Again, verify your diagram. How many boxes? How many boxes you can process in buffer memory?
4.
Brother, only three boxes we can process. No, 10
Oh,
numbers
oh, yeah,
not
yeah.
available. So acknowledge is 7,
8, 9.
8, 9.
9.
Bob say, okay, last time I am sending 4, but you are sending acknowledges only 3. So that means Sam, how many packets memory? 3 packets. Clear? And now Sam say, brother, I am sending one more message after acknowledge. Retransmit. Which one? Retransmit. Which one number box? 10 number. Bob will send 10 number. Sam will send acknowledge. So basically this task called windowing. Which one task, dear? This process only first time we do, next time we are not doing with devices. Clear? Only one time. After know the buffer memory, no need to process again and again. Clear?
Question here. Why in the beginning, why you didn't take, for example,
Huh?
3? Why you didn't take 3 from the beginning instead of 1?
It's the only method to teach a buffer memory
Oh,
concept.
method. Okay, okay. All right, okay, got you.
Because in real time, we are not having a 3 packets. We are getting in MB, 4 MB buffer memory, 5 MB buffer memory. Clear?
Okay.
Now one more thing. Basically, in sequencing, one more option you can remember. If someone asking if inside my network, we are having a multiple different types of devices, router, switch, firewall, access point, printer, camera, firewall. So how to know which one is my lower MTU, which one is a higher MTU? So basically we are using one protocol. It's called PMTUD. This protocol by default enable every networking plus PC laptops devices. PMTUD. What is the name? PMTUD. Path MTU Discovery Protocol. Which one name, dear? Path MTU Discovery Protocol. This protocol by default enable. Read this line, dear. You can get idea. Hold on. I will select. Okay, read this selected lines only. Anyone can read.
Path MTU discovery is a standardized technique in computer networking for determining the maximum transmission unit size on the network paths between two internet protocol hosts, usually with the goal of avoiding IP fragmentation.
If someone asking what is the fragmentation, data slicing. And what is the windowing? To know about the buffer memory. Clear? How much data you can process. Any doubt?
Question for you. The MTU usually it is 200 on the network card itself, or what's the default number?
Basically, in real world, we are using a PC, laptop, printer. So by default, 1500. Clear? But if you're working as a network engineer, so sometimes you are getting a jumbo packets. Which one packet, dear?
Jumbo frames.
Jumbo packets, jumbo frames.
Okay.
Basically,
Okay.
jumbo packet means we are adding multiple information with my packet. So we need to increase my MTU size. So this thing can be possible on routers, firewalls. Clear? We are using MTU changes. We are not using any changes with PC laptops. Clear? By default 1500 bytes. Okay. So if you want to change, so possible. But right now, which condition if you're having a jumbo packets? Clear?
Is it the same as jumbo frames?
Yes, same.
But this one need to be enabled.
Yes, we need to enable.
Yeah.
Okay. Now, how many feature we discuss? 3 feature. Now, fourth feature we also discuss. Fourth feature name is reply. And fifth feature name is dear acknowledge. Reply means successfully receive data. And acknowledge means dear how much size data received. Okay. Any doubt? But UDP will do these things. UDP will do connection oriented. No, it's a connectionless. That means never do UDP three-way handshake. Never do sequencing. Never do flow control. Never do reply and acknowledge. But data we are getting quickly process. Which one, dear? Quickly process. This thing is clear? Loyal, Neil, Gopi. Any doubt?
Yes.
Yes.
Okay.
Yes. That's fine.
Now, how many layers remaining now? I think we are getting network layer, data link, or physical. Okay. Go through this TCP features plus TCP protocol plus UDP protocol. And tomorrow, before tomorrow's session, I will ask 5 questions from TCP, from UDP. You need to go through these videos and find out which one is advantage, which one is disadvantage. Clear? For TCP, for UDP. Clear? Any doubt?
No.
Before doing tomorrow's session must be come with 5 advantage, 5 disadvantage with TCP, with UDP. Clear? Now, only tomorrow last session we do for OSI, then complete your data structure. Okay? Any issue? Loyal, Neil, Gopi?
No, nothing.
No. Okay. Okay, I will share CCNA new books. Okay, give me 1 second. Hold on. I'm sharing. Wait. Software. Check your Zoom chat. Uh, Gopi, your mail ID is? Spell your mail ID. This one? Loyal, your mail ID, Neil?
Mine is D'Souza Neil 206.
D'Souza.
DSO.
DS?
It's OUUZA.
DSOUDA.
ZA. DSOUZA.
Why
A.
I'm not?
Neil.
Kusum Saigo.
No, this one is not available. Hold on. I think 1 second.
I shared in chat.
No worry. I have no
Yeah.
one. This folder also available your mail ID.
Yeah, that's mine.
Yes.
Yeah, that's right there. Yeah.
Download this CCNA new books and old books, okay? And read the topic one only from your books, OSI model. Okay. Verify. Are you receiving the mail? All users. In this folder, this books is a new books. In this folder, we are getting a old books. Clear? Lab workbook, simulator, software, everything available in this folder. Clear? Everything. Project also available for CCNA.
Where can I find them? Did you share them?
Yeah, already shared. Na?
Uh,
Check your Google Drive. Are you receiving?
I got it. Yeah.
Yeah. Open the day one. Open the topic one and read OSI model before network layer data or physical. Clear?
hold on. I cannot see it. Oh, okay. CCNA book software.
Yeah.
I have a question for you. Still, CCNP still there?
Okay, Loyal Neil Gopi.
Yeah.
Yeah, still